Hey, this is Arkeith. I spent days pulling out my hair working on some stuff for my game, but I got some road gain and I'm back with another update. This is Devlog number 2. First thing is first, I'll go over some of the small changes. I mean, they seem small, but no kidding, some of these changes took me an embarrassingly long amount of time to do. One change that I felt had to be done was upping the resolution from 320 by 180 pixels to 470 by 270 pixels. 320 by 180 just felt too zoomed in and there really wasn't much space to see the surrounding environment. I think this change is for the best and I'd say it looks much better. Next up is making the cave entrance. Rather than walking to the end of the map to move to the next scene, I figured it would be more of an immersive experience to draw out the cave entrance. The cave looks a bit questionable as of now, but I'm sure with some polishing it would look much better. Stay tuned. Last small change is implementing consumable items. Recording the drinking sound was fun, but surprisingly more involved than I thought. I feel like sound effects are crucial, at least for players to get immersed in the game. And if it's annoying or jarring, then it ruins the gameplay. So with that being said, here are some of my attempts. Oop. Oh, that's so much water. Finally getting a sound that works, you could say quench my thirst. I still have to do an eating sound, so look forward to that. Or don't. That's a summary of the minor changes. Now, onto the juicy stuff. I first want to talk about Tilemap lighting. Okay, so I already know this was in my last devlog, but it's important for the performance, what should I call it? Journey that I spiraled into, which I'll get into soon. To implement this 2D block-based lighting, I followed another YouTube video by Gonkee. You guys should check it out, it's really helpful and a great video. I'll leave a link in the description. I implemented this lighting system in GDScript, and it worked just fine, but it was quite slow. This is because when lighting up a block, it recursively lights up adjacent blocks, and they in return recursively light up their adjacent blocks. This results in thousands of function calls to figure out the light values at each block. And when my player moves, I would have to recalculate the light values because I don't have the entire world loaded in at once. And this brings me to my next feature, chunking my tile map so that I don't have to have the whole map loaded in at once. Here's a quick crash course on how my tile maps work. I generate maps using a seed and a random number generator. With the same seed, I can get the same results deterministically. So all I have to do is take the x and y coordinates, hash it into a key, and then use it to seed the random number generator, and with the result, I decide which tile to place. If I use the same algorithm to hash the key that I used to seed the generator, then the tile map rendered will always be the same, allowing me to get away without saving the map data. Chunking my map allows me to render only the tiles that is closest to the player, so I can save on memory. Right now my chunks are 28 tiles wide and 18 tiles high, and I load 9 chunks at a time, like a grid in which the player is in the center chunk. This way I can keep the program's memory constant. However, there is one problem I faced with this chunking system. It's that since I don't have the whole map in memory, I would have to render the tiles during game runtime whenever I load a chunk, and that caused a stutter in my game. So with the 2D lighting system that had thousands of recursive calls, and my chunking system which also took quite a while loading new tiles, there was a performance monster that I had to address. Here's the amount of milliseconds it took whenever I had to load new chunks with the new lighting values when my player moves. You can also see the huge stutter. Don't need to tell me, I know it looks great. This is the result of using GDScript, which is a scripting language integrated with the Godot engine. Since GDScript is dynamically typed, it just wasn't performant enough to do what I wanted. That's why I resorted transferring the lighting and chunking systems to C++. Once that was done, here are my results. I was able to reduce the 800 milliseconds of computation time to around 20 milliseconds per frame. As you can see, this is a huge improvement, but I still faced a slight stutter that I wanted to get rid of completely. I tried multi-threading, but the performance game just wasn't good enough. After several hours, I figured that I didn't really need to improve the time it took to perform the calculations, but rather I could just split the calculations into 2 frames rather than doing it all in 1 frame. I split the lighting calculations and the chunk rendering into 2 separate frames, and I was able to get no stuttering and the lighting and rendering worked just as expected. And with that, I was able to deal with the monster that was performance. Next up is terrain generation. The mines before looked awfully boring. It was just super flat, so I wanted to spice things up with some noise. Before that, I have to give a huge credit to this article about 3D Cube world level generation, which I used to generate my terrain. I'll leave a link in the description if any of you are interested. First, I used a noise library called Fast Noise to generate a better height map. Right now I have 3 types of surfaces, which include lowlands, highlands, and mountains. I plan on doing more tweaking to add more variation later on. Next, I try to do some cave generation, which still needs quite a bit of work, if not a lot of work. I want to add some small cave openings at the surface in which the player can go down and slowly explore something even bigger. A lot more to do, but so far, I'm feeling pretty good. To summarize, I struggled to stop my player from stuttering, made my terrain noisier, and I also drank a bit too much water. You guys take care and don't forget to subscribe. I gotta get to the washroom now.